السلام عليكم ورحمة الله. كيف الحال يا شباب؟ إن شاء الله تكونوا بكل خير. طبعا محاضرتنا اليوم راح نكمل فيها عن اللي هو الموضوع اللي كنا بدأنا فيه، اللي هو equation of a plane and the different يعني applications on this subject. طبعا let me share the screen and go to the notes. So I guess we reached to this point where we solved the example about this plane that crosses the x, y, and z axis at point 1, 2, and 3, and we were able to find the area of this triangle. Okay. Let me start with this example. The example says that an infinite column. We have an infinite column that is centered along the z-axis. It has a square cross section of side length 10. It is cut by the plane. This plane. What is the area of the surface cut? Okay, let me show you what is this example about. So first of all, it says we have an infinite column. Infinite column means we have a column that is centered at the z-axis. So this column goes from minus infinity to infinity. Okay. Okay, this is our column. Now we have it's centered along the z-axis. Okay, each side of this column has a length of 10. So this side has a length of 10. This side has a length of 10. This side has a length of 10, and this side has a length of 10. Okay. Okay, so the column is centered. So this surface is a square. Okay, and it's centered along the z-axis. So we can find the coordinates of these points, the corner points of the column. Okay, so this point is 0. The center point is 0, 0, 0 in the x, 0 in the y, and let's give it a value of z, some height in the z direction. But the x component is 0, the y component is 0 because this is the center. Now, if you want to find the coordinates of this point, okay, so this is the center, okay, 0, 0, x is 0 and y is 0, and it has some height which is z. Now, the length of this side is 10, so we have 5 in this direction and 5 in this direction. The same holds for this side. So we have the total length is 10. So we have 5 here and 5 here. Okay, the same holds for this side and this side. So this is here, it's 5 here and 5 here, and here it is 5 here and 5 here. Let us use this information to find the coordinates of each of these points. Okay, let's call this to be P1, this P2, and this is P3, and this is P4. Okay, now the question is telling me that there is a plane. Okay. Right. Let me first, before talking about the plane, let's find the coordinates of these points. Let's come to point P3. Okay, P3. What's the coordinates of P3? So we start here, it's 0, 0, Z. Okay. If we move to this side, we are moving in the Y direction. How many units we are moving in the Y direction? 5 units to the left. Mashi. So this represents -5 in the Y direction. And moving this way, it represents 5 units in the X direction. So the components of P3, of point 3, is 5 units in the X direction, -5 units in the Y direction, and it's Z. We don't know the height. Let's call it Z3 or Z. For now, it's Z. Ashi? Let's go to point P1. P1. This is P1. So yes, okay. Now for P1, we have we move this way, 5 units in the Y direction, in the positive Y direction, and then we move 5 units in the positive X direction. So the coordinates of point 1 is 5, 5, and Z. Okay. The same way we can find the coordinates of P2. So P2 start at the center. You move 5 units in the negative X direction, and then you move 5 units in the positive Y direction. So the components of P2 is -5, 5, and Z. Okay. And the last thing is for point P4. We move 5 units in the negative X direction, and then 5 more units in the negative Y direction. So the components of P4 are -5, -5, and Z. Okay. This is the components of the 4 points. Okay. If the components of the 4 points, if this square is at one height, at one level or one height. So the components have all these points, because they are on the same level or the same height. They have the same Z components, the same height. They differ only in the X and Y components, but the Z component is the same. Okay. Now the question is telling me that there is, what happened is that there was a plane. Okay. A plane that, you know, اللي هو a plane that crossed, or yeah, the question is telling me that there is a plane. Okay, that plane, this plane, the one in orange, cut this column, the column in blue, the infinite column, there it's in blue. There is a plane, the orange plane, it came and cut this column in this way. بشكل مائل, okay? This plane came from behind the column and cut the column, and it came out of the column from the other side. Okay? So this is the plane from the back and the front of the column. Now, the plane, when it cut the column, it cut it arbitrarily. Okay, cut the column arbitrarily. So the question, the shape that formed by the cutting process is a shape that's not necessarily a square. Okay, it could be a diamond, it could be a parallelogram, we don't know, but the shape formed by this cutting process is a shape that has 4 sides, but it's not necessarily a square. Okay, so this shape, the one in orange, this is inside the column. Okay, it's like, let's say this is the column. Okay, and let's say that this is the plane cutting the column. It came from one side and it came out of the column from the other side. So the shape formed from the cutting process between the plane and the column is a shape with 4 sides. Okay, now the question is telling me to find the area of this shape, the one formed from the cutting process. Okay, so what is needed is we want to find the shape of this, we want to find the area of this surface, or the area of this shape. Again, this shape is inside the column. I'm just drawing it for the clarification purposes, okay? But if it was a real process, we will not see this shape. Okay, so the thing is that we need to find the area of this shape. Okay, now in order to for any shape of 4 sides, we can find the area of this shape easily by what? The area of any parallelogram, or yes, the area of the parallelogram. It should be a parallelogram. Yes, the area of the parallelogram is given by, is equal to what? So the cross product, let's say we have 2 vectors. This is vector v1 going along this side, and we have this vector v2 going along this side. If we have the cross product between these 2 vectors, we can find the area of this shape. So the area of the parallelogram formed is equal to the cross product between v1 and v2. Okay, and then we take the magnitude of that cross product. So the process is easy, but in order to find the vectors v1 and v2 that we need to use in the cross product, we need first to find the vectors v1 and v2. In order to find these vectors v1 and v2, we need to do what? We need to find the exact coordinates of each one of the 4 points of the parallelogram shape. Okay, so we have 4 points. We want to find the components of these 4 points, and then we can form distance vectors between each 2 points, and then we after finding these distance vectors, we can find the cross product. So we can say v1 is equal to distance vector between point p1 and p2, and v2 is the distance vector between p1 and p3. Okay, so to find the coordinates of the 4 points, what we need to do is first we at this shape, I said this is a square shape, and it has the same level or same height. That's why we put the z component here for this, all of the points the same. We assume that all the points are at the same height, so we give the same z component for each of the 4 points. Okay, but in the general shape here, we can't assume that the z component for each of the points is the same. Each of these points will take its own height or its own z. Okay, so we use the same coordinates as these points, but we have to modify or change the z component. Okay, so the z component or the new components of the 4 points will be like this. So P1 is equal to 5, 5, and we call Z1. Okay. For P2, we have -5 and 5 and Z2. For P4, we have -5, -5, Z4, -5, -5, and Z4. And for P3, we have 5 and -5, 5, -5, and Z3. Okay, so we have the components of all the 4 points, but with each point, we have only one unknown component, which is the Z component. Okay. Now, how do we find the Z component of each of the 4 points? The thing is that these 4 points, 1, 2, 3, and 4, they lie on the plane, on the orange plane. Okay, so yeah, so if these points lie on the same plane, then they should satisfy the plane equation. Okay, so we try substituting each of these points in the plane equation, and then we find the unknown Z. Okay, so for point P1, which is P1 is 5, 5, Z1. Okay, so 5, 5, Z1. We substitute in the plane equation. What's the plane equation? It's given here. So the plane, let's call it plane pi. This is plane pi. So plane pi equation, it's 4x minus 7y plus 4z equals 25. Okay, so substituting in the plane equation for point P1, which is given by what? 5, 5, Z1, 5, 5, Z1. So it becomes, the plane equation is given by what? So we have 4 times 5, 20, minus 35, plus 4Z1 equals 25. Okay, so we have minus 15. So 4Z1 equals what? 40. So Z1 is equal to what? To 10. So the height of point P1 is 10. So this, we put 10 here. Instead of Z1, we put 10. So these are the components. Now the coordinates of point P1 are all known now. Now we substitute for point P2. So pi at P2, which is, we said P2 is minus 5 and 5, minus 5, 5, Z2. Okay, so we have minus 20, minus 35, plus 4Z2 equals 25. We have minus 55 plus 5, minus 55, 60, 80. So 4Z2 is equal to 80. So Z2 is equal to 20. Okay. So this one, Z2, is 20. It's 20 here. Now we substitute for P3, pi at P3. P3 is given by what? P3 is given by 5 minus 5, 5 minus 5, and Z3. Okay, so the plane equation is 20 plus 35 plus 4Z3 equals 25. Okay, so شو بصير عندنا هون؟ We have 5 minus 35 minus 35 اللي هي ايش بصير؟ هون اوكي for x. I'm going to 5 minus 5. Okay, so we have 20 here plus 35 plus 4z3 equals 25. Okay. So if I know 4z3 is equal to 5 minus 35, it's equal to minus 30. So z3 is equal to 30 divided by 4, which is equal to what? Which is equal to 7 minus 7.5. Good. So minus 7.5, let's see. We have 5. Okay, 5 minus 35. 5 minus 35 is equal to minus 30 there. Okay, so let's see, 5 minus 5, 20 minus 35 or plus 35 plus 4z3 equals 25. Here we have 4z3 is equal to 25 minus 20 minus 35. Okay, this is 5 minus 35. It's minus 30. So 4z3 is correct. 4z3 is equal to minus 30. So z3 is equal to 7.5. Okay, 7.5. This is not correct. This is minus 10. You should change it. It's minus 7.5. So z3 is equal to minus 7.5. Here, minus 7.5. Okay. And then the last thing is point P4. Okay. So P or pi at P4. P4 is given by minus 5, minus 5, minus 5, minus 5, minus 5, and Z4. So it's gonna be like minus 20 plus 35 plus 4Z4 equals 25. So we have 15. 25 minus 15 is 10. So 4Z4 is equal to 10. So Z4 is equal to 2.5. Okay, so the last coordinate here is Z4 and it's equal to 2.5. Okay, now the coordinates of all the 4 points are known now. So the next step is that we form the distance vectors RP1, P2 and RP1, P3. Okay. So RP1, P2 is equal to what? P1, P2. Where's P1? Where's P2? So this is P2. This is P1. So minus 5 minus 5, it's minus 10 a sub x. 5 minus 5, it's 0. And then 20 minus 10, it's plus 10 a sub z. The next vector is our P1, P3, which is between P3 and P1. So we have 5 minus 5, it's 0. Minus 5 minus 5, we have minus 10 a sub y. And then we have minus 7.5 minus 10. It's minus 17.5 a sub z. Okay, now the two vectors are there. Now, what we need to do is to find the cross product between them. So RP1, P2 crossed with RP1, P3 is equal to what? The a sub x, a sub y, and a sub z here. RP1, P2, it's minus 10, 0, and 10. And the other vector is 0, minus 10 minus 17.5. Okay, and we calculate the determinant for this. The determinant should be equal to what? A sub x 0, 0 plus 100, so it's 100 minus a sub y minus or 175 plus a sub z 100 times 100. Now the last step is to find the magnitude of this cross product. So the area is equal to the magnitude of the cross product between RP1, P2 and RP1, P3, which is equal to 100 squared plus 175 squared plus 100 squared, and we find the square root of the whole thing. So the square root is equal to 225. So this is the area of the parallelogram formed by the cutting process of, between the plane and the column. Okay. Let's see the final result here. It's not, it's bigger than final result we got. We got 225, but here the notes are having the final answer or the area as 244.95. That's because of the this component. We found this component to be minus 7.5, but here they were mistaken and they calculated this value to be minus 10. So that this change or this difference affected the final value of the area. Okay, but our calculations is the correct one. Okay, let's move to, okay. Okay, this example is asking us to find the angle between two planes. Okay, the two planes are given. This is plane, let's call it pi 1, and this is plane pi 2. So we have the equation of each of these two planes, and the question is asking us to to find the angle between these two planes. Okay. Okay, let me talk a little bit about this here on the whiteboard. So for the planes, if you want to perform any calculations between any two planes, like you want to find the cross product, you want to calculate the dot product, or any kind of calculation between two planes, you can't do these kinds of calculations between the two planes themselves. Okay, you need to associate with each of these two planes their normals. So the normal, it's like if we're talking about a person, we want to talk about him, we call that person by his or her name. Okay, so the normal vector related to the plane, it's like the name of that plane. So any kind of processing we need to apply on the plane, we use the normal vector for the planes. So always and each time you want to use the plane, first you have to look for the normal of that plane, and then you can proceed with your calculations. So now we have the two planes, plane pi 1 and plane pi 2. With the given equations, the equations are 2x 2 3 minus 5, 2 3 minus 5 equals 6. The equation of the other plane is 3, 8, 6. 3, 8, 6 equals, I think, 8, 9. Okay, these are the equations of the two planes. So now what the next step, the next direct step is that we need to find the normal vector for each of the two planes. So n1 is equal to 2, 3, and minus 5. And the normal vector for plane 2 is equal to 3, 8, and 6. Okay, these are the two normal vectors. Now, if we want to find the equation between the the angle between these two planes, we can use the normals to find the angle between these planes. So let's use the dot product to find the angle between these two planes. So n1 dotted with n2, it's equal to what? 6 plus 24 minus 30, which is equal to 0. Okay, so if the dot product between two vectors gives me an answer of 0, then that means that the two vectors are perpendicular to each other, right? If the two normals are perpendicular to each other, then that means the planes are perpendicular to each other as well. Okay, how is that? Let's look at these two planes. This is one plane. This is plane pi 1, let's say, and this is plane pi 2. This is pi 2. This is pi 1. Let's say these two planes are perpendicular to each other. This angle is 90 degrees. Okay, now let's find the direction of the normal of each of these two planes. The normal to this plane is in this direction. This is n1. And the normal to the other plane should go this way. Okay, this is n2. The angle between the two normals is 90 degrees. So here it's 90 degrees between the planes, and here it's between the normals, it's 90 degrees. Okay, so if we find that the two normals are perpendicular to each other, then that means the two planes are perpendicular to each other as well. Okay, but this is the special case that the two planes are normal to each other. Now let's take another case where the two planes are not perpendicular to each other. Okay, this is plane number 2. Let me delete this one too as well. So this is the first plane, and the other plane is like this. Somehow, the drawing is not very accurate, but at least it can show what I mean. So this is plane number 1, the one in blue. Okay, and the other one is the orange one. Okay, these are the two planes. Now, clearly, the angle between the two planes is not 90 degrees. Okay, it's this angle. It's below, it's less than 90 degrees. Okay. Now we want to find the angle between these two planes. We call this angle to be theta. Okay. Let me, this is pi 1, this is plane number 1, and this is plane number 2. Okay, the angle between them is theta. Now, again, in order to find this angle, we must use the normals of these two planes to find that angle. So the normal of the blue plane should go like this. The normal should be something like this. This is N1. Okay, and the normal, of course, you have to remember the normal, I draw it, in this case, going out of the plane. Right. The normal to the other plane, the orange one, is something like this. Okay, this is N2. Okay, now the angle between the two planes, between the two normals is this angle. Let's call it theta prime. Okay, now in order to find the theta prime, what you need to do is you perform the dot product between the two normals. So N1 dotted with N2 is equal to the magnitude of N1 times the magnitude of N2 times cosine theta prime. Okay, now we find this theta prime using this relation. Now theta prime is found now, but we are not asked for theta prime. The question wants us to find theta. The relation between theta and theta prime, we can find it through this diagram. Now, if we finish this line like this, the other direction like this, okay? And we'll finish this line like this. Okay. Okay. Let's draw a line from here. This line, let's call it L1 and L2 are parallel to each other. Okay. Now, okay, now let's do it in another way. For this line, okay, this line is perpendicular to plane pi 2. Okay, let's call it L1. L1 and okay, L1 and N2 are parallel to each other. And now we have this and this. This is 90 degrees. This is 90 degrees. Okay. Right. Okay. Okay, I will talk about this later, but what we I will show you how we find it in the next lecture. But the thing is that the theta prime we find between the two normals is equal to the relation between theta prime and theta. Theta is equal to 180 minus theta prime. So let's say we found like theta prime between the two normals to be, for example, 100, okay, then theta will be equal to 80. Like if theta prime, which is the angle between the two normals, is equal to 100, then theta is going to be 180 minus 100, which is equal to 80 degrees, okay? So it's the complement. So theta is the complement with the complement of theta prime. So whatever angle you find between the two normals, it should be the complement of the actual angle between the two planes. Now we return to this case when the two normals were perpendicular to each other. So the angle between the two normals was which is theta prime, was equal to 90 degrees. And when we wanted to find the actual angle between the two planes, it was the complement. It was the complement of theta prime. So it's equal to 180 minus 90 and should be equal to 90 degrees. So theta is equal to 90 degrees. Okay. Okay. let's get back to this example. Before we do this example, we should know something before solving this example. Okay, the things that we need to do first, the first equation we need to know is that how you find the distance between a point and a plane. Okay, so we have a plane given, so this is the plane equation, and we have a point somewhere in the space. We want to find the distance between this point and the plane. Okay, this is how we derive this relation, but you can look at the derivation on your own. It's easy, but the thing is that the final relation that relates the distance between the point and the plane is as follows. So we have the distance. It is the distance between point x node, point x node, y node, and z node, and the plane ax plus by plus cz plus d equals 0. So this is the distance between the point and the plane. So the distance is equal. You substitute the components of this point in the plane equation. Okay, as you can see here, x node, y node, and c node. And then you divide by the magnitude of the normal vector on the plane. So you divide by the magnitude of the normal vector on the plane. So the normal vector on this plane is equal to a, b, and c. So you divide by the magnitude of the normal vector. Okay, this is one thing we need to know. The other thing that we should know is that how to find the distance between two planes. Okay, so the distance between two planes. Let's say we have these two planes. This is plane pi 1, and the other plane is and this is plane pi 2. Okay, so we want to find the distance between these two planes, the normal distance. Okay, so this is D. We want to find D. Okay, first of all, these two planes, in order to find the normal distance between them, the only case you have to find the normal vector between, the only case you have to find the distance between two planes is that you have to have the two planes to be parallel to each other. Okay, the two planes should be parallel to each other. Okay, if the two planes are not parallel to each other, if it's something like this, then at some point the two planes will intersect each other. One plane will cut the other, and the distance between them will be 0. So the only case we find the distance between the planes is that when the two planes are parallel. Okay, now when the two planes are parallel, then their normal vectors should be the same. Okay, so the only thing that the equations of the two planes are different is in the constant term. Okay, so this is plane pi 1 and this is plane pi 2. If we look at them, they have the same coefficients, A, B, and C, because they have the same normal. Okay, but the only difference is that they differ in the constant term. Okay, so So yeah, in order to find the distance between these two planes, you take the constant term of the first plane minus the constant term of the second plane. You take the magnitude of that, and then you divide by the magnitude of the normal vector. Okay, so this is how we find the distance between two planes, two parallel planes, of course. Right. Based on this, let's do this example. The example is asking me to find the distance between the two planes, which are plane number 1 is this 3x plus 2y minus z plus 5 is equal to 0. This is plane pi 1, and the other plane is 6x plus 4y minus 2z minus 12 is, which is plane pi 2. Now, before we go ahead and put the parameters in the equation, we have to make sure that the two equations are normalized. If they're normalized, then they will have the same coefficients, that like the coefficients of the x, y, and z should be the same before we start using the equation. Okay. Now, if we look at the equation of these two planes, we see that the coefficients here, 3, 2, and minus 1 are not the same in plane pi 2. Pi 2 has this coefficient, 6, then 4, then minus 2. Then they're not the same. Then before I go ahead and use the equation, I have to normalize. Which plane equation should I normalize? It's, of course, it's the equation of pi 2. Okay, we notice that the coefficients in the equation of pi 2 are multiplied by double of the coefficients of the equation of pi 1. So we divide the equation of pi 2 by 2, so it becomes like this. So pi 2 is let's divide by what? 2. So 3x plus 2y minus z minus 6 equals 0. Okay, now if we compare the coefficients in the two equations, here it's 3 and here it's 3, here it's 2 and here is 2, here it's minus 1 and here is minus 1, then we're good to go. Okay, we can use the equation now. So the equation says that d is equal to the difference between the constant terms in the two equations, which is 5 minus 6, okay, divided by the amplitude or the magnitude of the normal vector, which is 9 plus 4 plus 1. Okay, this is equal to what? This is equal to 11 divided by square root of 14. Okay. Of course, when we want to find the distance, we have to put the two equations in the standard form. Okay, the constant term here and the constant term here should be what? Should be on the left side of the equation. Okay, if the equations in the question were given like this, like plane pi 1 is equal to 3x plus 2y minus z equals 5, and pi 2 is given by 3x plus 2y minus z minus 6 equals 0. You can't use the constant terms like this. You have to put the two terms, the two constant terms on the same side of the equal sign. So this 5, you put it here, becomes minus 5, and this minus 6 is already at the left side of the equation. So you can, then you use them in the equation. Okay, so this is how you find the distance between two planes. Okay. We talked about this. Okay. Is to let's do this example. No, not this one. This one. Okay. Let's do this example. This example is asking us to find the equation of the planes. Find the equation of the plane, sorry. Yes, find the equation of the planes. Equation of the planes. Planes, that means there are more than one plane that are parallel to the plane, this, and the perpendicular distance from these planes to this point 1, 2, 3 is 1. So let me show or explain further. So we have this plane, let's call it pi. So we have this plane pi. Okay, this is plane pi. There are planes that are parallel to this plane pi, and they have a perpendicular distance, and there is this point. This point 1, 2, 3 lays on this plane. Let me change the color here. It's not clear. So again, we have the plane pi. This point 1, 2, 3 lies on this plane. Okay. The question is asking me to find the equation of the planes that are at a distance of d equals 1 from the point 1, 2, 3. Now, the only two options that are available for me here is to find a plane that is above the plane pi. A plane, let's call it pi 1. Pi 1 is above the plane pi. Okay, this is pi 1, and it has a distance of d being equal to 1 above the plane pi. And the other option is another plane which is under the plane pi. Okay, and it is having a distance of d equals 1 from the point 1, 2, 3. So the available two options for the planes we are going to find their equations are two planes. One is above the given plane and one is under the given plane, and both are at a distance of 1 from point 1, 2, 3 on the plane pi. So again, point 1, 2, 3 lies on the plane pi. Okay. So what we are given is the information we are given in the question is the distance d. It's equal to 1. But as long as we are dealing with the distance d one time above the plane and the other time it's under the plane, then we give that distance two signs, plus, minus 1. Okay. So the plus 1 is indicating that the distance is above the plane, and the minus 1 is indicating that the other distance is under the plane. Okay, this distance, we use the equation for the distance. We say the distance between a point and a plane. How do we use this equation? The distance d is equal to, so we have the equation of the plane. So it's x naught minus 2y naught plus 2z naught minus 3 divided by the magnitude of the normal vector, which is 1 plus 4 plus 4. We take the square root. Now, this x naught, y naught, and z naught represent what? Represent the components of this point, which lies on the plane pi. So we put here the components of the point. So we have x naught is 1, y naught is 2, and z naught is 3. Okay. Now, so the only, oh, of course, yes. There's one mistake here. We need to be careful about it. This is the equation of the plane we are trying to find its equation. So this is the unknown equation. So this is the unknown plane, which is pi 1 and pi 2. Okay, so we substitute for this equation 1, 2, 3 that lies on plane pi. We substitute it in the equation of pi 1 and pi 2. Okay, so k here, the constant term is not known, but what is known here is the distance d. We said the distance d is plus minus 1 to refer to the direction. One time the distance is above the point, and the other time the distance is under the point. So we have only one variable, which is k, and we solve for k. So we have 1 minus 4 plus 6 minus k is equal to what? Is equal to plus minus 1 times square root of 9, okay? So 1 minus 4 is minus 3, plus 6 is 3. 3 minus k is equal to plus minus 3. Okay, so 3 plus minus 3 equals k. So k is equal one time to 6, and the other time is equal to 0. So the two equations of the two planes are, so pi 1, the equation of pi 1 is x minus 2y plus 2z plus 2z plus 6 equals 0. And the equation of pi 2 is x minus 2y plus 2z plus 0 equals 0. So these are the equations of the two planes. Again, if you compare the equation of plane pi and pi 1 and pi 2, we notice they have the same normals. They have the same coefficients, 1, minus 2, and 2. But the only difference is in the constant term. So this is the relation between the parallel planes. They have the same normals, but they differ only in the constant term. Okay, okay. So I'll stop here. And inshallah, next week I will finish up with the rest of this material. Assalamu alaikum. Yes, regarding the quiz, I will let you know of the details of the quiz, inshallah, using the email. Okay, I will send you the information relevant to the quiz, inshallah, on your Gmails. Assalamu alaikum.